Okay, students, so yesterday we have discussed continuous function roughly, right? So you can note this down. Continuous function, what it is? In simple word, a continuous function is a function whose graph does not break at any point. Okay, means it is a function, those function whose graph does not break. So if I draw graph of this one, fx equal to x plus 2, you can see this will be the graph. The arrow sign implies that it will go on, it will never end. Okay, so this will go on. Okay, so there will be no break. So you can see in this graph there is no break, right? Means if I take a pen, if I draw this graph, what I have to do? Without lifting this pen, I can draw this graph. Without lifting, why? Because if there is no break, I don't have to lift the pen, right? If there is a break like this, suppose cap is there, then to draw this line, what I have to do? I have to draw till here, then lift your pen, and then you have to draw from here, right? So if there is a break like this, then it is discontinuous. Okay, so some example I have taken here. You can just see this graph is continuous. This function, obviously this graph means what? It is a function, right? Some function whose graph is this one. In this graph is continuous, means this function is continuous. You can see there is no break, an arrow sign I have given. This graph, I hope you remember this graph, sine function, right? This sine graph. So sine graph is also continuous. Not only sine, actually all the trigonometric function in their domain, it is always continuous. Why I say it in the domain, you will understand later. See here. So this sine function, you can see there is no break, right? It will go on. That's why I put arrow mark here again. This will go on, right? So this also continuous function. Is this continuous function? Now you can see this line here, it is continuous, but there is a break here, right? Now if I consider both the function together, then I will say that these functions are not continuous. You can see there is a break. Okay, this function is discontinuous, discontinuous or not continuous, I can say, right? Discontinuous. There's a break again. This is again continuous. You can see there is no break. There is a break again, so discontinuous. This is also okay. If you have graph like this also, then also this will be continuous. Okay, this will be one function, this will be another function. Okay, so this is also continuous function. So I hope you have understood graphically what is the meaning of continuous function, and the meaning is very important here. If you understand the meaning of what is continuous function, then using the limit concept also you can understand what it is. Okay, limit concept, exactly same meaning it will imply. Okay, so to understand in limit form, I have already written the definition, which is from your book only. You can write down this one. Okay, suppose f is a real function, okay, or a subset of real numbers, and let c be a point. Real function, what we used to take, domain and codomain, both we used to take real numbers, right? We deal with real number, that's it. Okay, the mapping which we used to deal with, we used to deal with only real numbers, then the function is said to be real function. Okay, suppose f is a real function or a subset of real numbers, and let c be a point in the domain of f. C be a point, this was the domain, right? Be a point on the domain of f. Okay, then then this function is continuous at c, when, if limit fx equal to fc, when x tends to c. Now this I have already explained yesterday. This is nothing but this one only, left hand limit x tends to c. When you can write down this one when your left hand limit and right hand limit are same, equal. Remember we have done in class 11 double definition. When your left limit and right limit both exist, then we can say the limit exists, this exists. Then we can write limit x tends to c. When we write limit x tends to c, try to understand that its left limit as well as right limit, means c minus and c plus both are same, equal, means it is approaching, fx is approaching at the same point. Okay, now simply listening will not help you. Okay, you need to analyze also whatever I'm saying. You take your paper, pen, and try to draw the graph and try to understand all this. Okay, I have already explained the limit concept. If you have not seen that video, see that video and try to understand limit concept yourself also. Try to analyze and try to understand. And this limit concept we brought from tabular form. Tabular form, try to understand properly, same meaning it was. Okay, So in this case, why they have said domain of, now when they use the term domain, student used to afraid. Don't be afraid. This is nothing. See here in your graph, what you used to do. Suppose fx is given x plus 2, right? This one. Now this graph, how we used to draw? X value we will take something, right? You will take 0. What you will get? Y. 2. x0, y2. So x0 means what? This is your domain. Y, fx, remember fx? It's your range, right? So x from where you are this c from where you are taking, from this domain only or not? So for that particular value, see here, suppose f is a real function of or a subset of real number, and let c be a point in the domain. Any point you take, any point means what? This x value you take 4, suppose. Okay, suppose 4 you have taken from here. So for 4 you will have fx, right? Something f of 4. So you can see in the domain of f, then f is continuous, then this function will be continuous when at c means at 4, if fx tends to fc. This is what the meaning, right? As x tends to c, fx tends to fc. Fc means what? F4 here. F4 will be somewhere here, right? Yes or no? So as your x tends to c, they have said, as your x tends to 4, like this, from left as well as right. This meaning I already told you, x tends to c means, this means from the left also, from the right also we are approaching. And when we get fx same value, means fx tends to same value, then we used to simply write x tends to c. Meaning is this one, left, right, both must tends to same value, then only you can write in this form. Okay, so when your x tends to 4, this is your c now. Okay, 4, your fx, you will see that if you take all this closer value, what you will get? Fx. If you take 4 here, what you will get? 6. So this will be 6 here. Okay, try to understand. 4 when I will take, it will be 6. Now if you take all this closer value, you will get all this close value here. Means what I can say, as you go closer, can you see this points? As you go closer to 4 from left, your fx also will go closer to 6 from left. Okay, as you go from right closer to 4, your fx also will go closer to 6 from the right. Okay, and at x equal to c, that is 4 I'm taking, right? 4, what is your fx? Fx will be exactly 6. So you can see all this point makes what? This, it makes this line, right? Can you see this line? It will make. So can I say this, at this point this function is continuous? See, it is not breaking. Understood? I am just checking at this point, at x equal to 4, the function will be what? This one. This will be continuous or not. To check this is continuous or not, you just have to check this line and this line is there or not, and it is joining or not. So for that limit concept, we can use limit from here, it approaching towards this one, right? And at this point, at 4, this point also exists. Means all these points are there, means these are continuous function. So at c, this one I have taken as example. Okay, at c, fc is continuous. This fc is continuous. Okay, this is what it means. So if you memorize this one also, then also you can solve the exercise. Okay, just you have to remember limit x tends to c, fx equal to fc, and most students used to do that only. And I know that some teacher used to explain in that way only, because they also know that student used to face problem understanding this one. Okay, this is little deep concept, but if your basic of limit is clear, then you will easily understand this one. This is nothing but we are doing tabular form only. Okay, we just want to find out this line is there or not. Function at c exists is continuous or not. To check that one, you just have to see this line is there or not. At this point, this side and this side line is there or not. So for that, limit concept is there to explain this one. Okay, so that's why I said simply listening will not help you. You need to analyze this one. You need to think again. Whatever I've said here, you need to think on other examples same way. Okay, same thing we will do in all the question, but we will deal with limit, right? So that's why student used to get confused there, because they don't understand this one. Okay, so if you understand this, easily you understand the exercise question also. Okay, so this is the definition. To prove fx is continuous or not at particular point, you just have to show this. Left hand limit x tends to that particular value c. Suppose I want to see find out at x equal to c if c is continuous or not. Function, right? Function will be continuous or not, I have to check. So fc will be continuous or not, we have to check. So for that, what you have to do, left hand limit you have to find out, right hand limit you have to find out, and it must be same, and at the same time fc also you have to find out that value, put it and find out. So most students used to memorize this one and solve, and I told you that memorizing this also you can solve the problem, but if they trick you with the problem, then it will be a problem. Okay, in multiple choice question mostly it is it create problem there. Okay, so next, so you can note this down. Okay, now next is, so example I have given, right? Now see, next definition they have given, this is for just particular point. This definition means at 4 I want to know function is continuous or not. So at 4, if I want to know, function will be which one? This one, right? Y. Function means what? Fx means what? Y only, right? Y value. This value is continuous or not. For that we used to check this line and this line is there or not. So limit concept we use. Now if I have to find out that the function is continuous or not, when they say function continuous or not means at all point you have to check. Okay, at all point means how you will check that? General form you have to explain that one. Okay, so for that also definition is there. You can see what is the definition. A real function f is continuous. This time not a particular point. Okay, all the function. A real function f is continuous if it is continuous at every point in the domain of f. Domain of f means what? All the value of x. Means if this ask you check for continuity of the function only, they don't mention at x equal to this or something like that, they don't mention. Suppose if they say only check continuity of function and they have given function fx equal to something, okay, and x equal to this, these things are not mentioned, means you have to check the function is continuous or not at every point. If they don't mention a particular point, then you have to check for every point. X equal to this, at every point you have to check whether it is continuous or not. Okay, so how you will check that one? In general way you have to explain that one. So that I will explain directly in the question only. Okay, so just try to understand the question. A real function f is continuous if it is continuous at every point in the domain of f. Domain of f, what they have said, I hope you have understood now. X value, because see, when you draw graph, what you used to do, x value you will take, for x value you will get y. So this x value are nothing but your domain, right? Domain of function. That's why they have said domain of f. Means at every value of x you have to find out here. Okay. Next. Now see here, algebra of continuous function, what it is. Now see, addition, subtraction of two continuous function is continuous. What does that mean? If you add two continuous function, means suppose you have a function f like this, continuous. This is f function, okay, fx equal to something is given, this function is continuous. Another function is given gx, and this is also continuous. Now they are saying that if you add this two continuous function, add means what? You will join it, right? Yes or no? Now if you add two continuous function, will it be continuous or not? Obviously it will be continuous, right? So addition and subtraction of two continuous function is continuous function. Product and division of two continuous function is continuous function. Okay, so you don't have to go in deep for this one. Okay, for first you try to understand the continuous function properly, then this you can derive yourself also later. Okay, so first just try to remember this one, addition subtraction of continuous. If your two function are continuous, these two function are continuous function, then if you add up, then that also will be continuous. If you subtract it, that also will be continuous. Product and division of two for continuous, f and g continuous, then if you product this one, then also continuous. If you take division, then also it will be continuous, provided that this denominator should not be 0, otherwise it will be undefined. Okay, so product and division of two continuous function is continuous function, provided denominator is not equal to 0. Okay, next, if two function are continuous, then its composition also will be continuous. Composition we already discussed in inverse trigonometry, right? So you might have understood this one properly. Okay, I mean in relation and function we have discussed this one, and in inverse trigonometry also. Anyway, so composition of two continuous function will be continuous again. Okay, if this function and this function is continuous, if you take composition of that two function, that also will be continuous. Okay, so you can note this down, this definition and this one also. Okay, I will send you the picture as well. Now in your exercise you will deal with three types of questions. What are the three types of questions? You see here, they will ask you check continuity of function. Okay, any function is given to you and they will ask check continuity at particular point only, they will ask. Okay, means when you draw graph for this one fx, you will get some graph, right? Some diagram like this. They will not ask you whether this whole function is continuous or not. They will just ask you at x equal to particular point, at x equal to 2 suppose, they will say check here whether the function is continuous or not. So how you will check at this point, how you will check the function is continuous or not? What you will do at this point, you will see fx is this one suppose 2, then this will be f2. At this point you will see it is breaking or not, this line. So this you have to find out only. So to find out this line and this line, what you will do? Limit concept, right? As you come closer to 2 from left as well as from right, your fx must come closer to this point from left as well as from right. If it happens so, and at 2 if you get f2, okay, then it will be continuous. Means what? This is what? Left hand limit, right? As your x tends to 2, how I will write down? Limit, how to write down? You have already learned that one in class 11, right? As your x tends to 2, fx must tends to what? To this point, and this point is what? f2, right? As your x tends to 2, I will simply write 2 now. I will not write left hand limit means minus, then again limit fx plus, because you have already understand from the graph, right? I have to write down left hand if you want to understand. Okay, let me write down here. Limit, how you write down? Fx, x tends to 2 minus from left. When your x tends to 2, your fx must tends to what? This point, f2, right? And when you move from right, limit fx, x tends to 2 plus, means as you move towards x from the right, x tends to 2 plus, your function must tends to towards this point only, f2, this point only is equal to, okay. So if your left hand limit as well as right hand limit, if it approach towards same point, okay, approach, when I say approach, it will come closer to the point, but it will not touch the point. So to make this point also along with this line, to include this point, what you have to do? You have to find out whether this point also there or not. So how you will find out? f2 means 2 you take it and put in the function. f2 is there or not, you check. So it must also be equal to this one. Okay, so this one how you can write? Limit x tends to 2 is equal to f of 2. Okay, this was the definition or not? Same thing. Okay, so this was the definition there which I was explaining you. Okay, so if you memorize also, then also you can solve problem, but if you can understand, you can solve better all the questions, you can solve it easily. Okay, otherwise if you memorize, what will happen? I told you, you will get confused in some question. Okay, so question, they will give you check continuity of fx at x equal to a. So for this point you have to check like this, at particular point they will give. Next type of question, they will simply say check continuity of function. So they will give fx equal to x plus 2 like that they will give, and they will directly ask you check continuity of this function. They will not mention at x equal to. So if they say like that, so you have to check continuity for all x, you have to check, not only for particular point, for all x. Okay, so how to write that one in question I will explain. Okay, next the last important, which is which mostly in exam they used to ask. Okay, find the value. They will ask you to find out value of some constant. Okay, they will give you some equation like this, fx equal to kx plus 3, like that they will give kx, and they will ask you find the value of this one if the function is continuous. They will give you that the function is continuous. Okay, they will give you this function is continuous and they will ask you find the value of k, some constant they will ask. So this kind of question you will get in the exercise, these three types. Okay, and mostly they used to ask this question number 3. So let's move to exercise and try to understand the topic well. Okay.